Okay, so today we're going to look at graphing quadratics in intercept form. So in intercept form, you have this equation, and this is the formula to find the vertex for intercept form. Yesterday, we went over standard form, and this was the formula for the vertex for standard form. And then the day prior to that, we went over vertex form, and the H and the K is the vertex for vertex form. And remember, vertex form is the one we love. So the three different forms, what are the key characteristics of the three different forms? They all have something that is easy to read about them. So in vertex form, obviously you can just see with your eyes what the vertex is, and you don't have to do any math to find the vertex. So that's why, one of the reasons why we love that form. And then obviously we can tell if the parabola is opening up or down. If it's negative, we know it's opening down, and therefore it would have a maximum of positive 2. So very quickly to find the maximum or the minimum to know if it's opening up or down, but basically we know the vertex very quickly. So we can tell the vertex by just looking at the H and the K, and we don't have to do any math. With standard form, it's a little bit different. Standard form, you have to do the formula to find the vertex. But what standard form does is it allows you to find the y-intercept very quickly. So in this particular problem, it allows you to find the y-intercept really quickly. So if you were to plug in a 0, right, because y-intercept is when the y is 0, or I'm sorry, when the x is 0. So if you took this equation and if you plugged in 0 for all the x's were, every single time you're going to end up just getting the constant as your answer. So the actual c is always going to be the y-intercept. Because when you plug in 0, you just end up with c, or you end up with the y-intercept. So you can quickly find, if it's in standard form, you can quickly see where the y-intercept is going to be in the graph. But if you want to find the vertex, you'd have to do a little bit of math, and we know if it's opening up or down because if it has a reflection or not. So that's the key characteristic of standard form. Not all that great, but it gives us a little piece of information. With intercept form allows us to find the x-intercepts really well, right? So with intercept form, we can find the x-intercepts quickly. So notice that this is a positive 3, but the x-intercept was negative 3. And this x-intercept, this was a minus 2, but the x-intercept was a positive 2. So we can very quickly see what the x-intercepts are. So we've got the three different forms: vertex form, standard form, intercept form, and they all have a good key characteristic. And obviously we can see whether they're opening up or down in all of them. So let's take a moment and let's go through the intercept form, because right now we're looking at the intercept form. So with intercept form, we first want to identify the P, and then we want to identify the Q, so that we can find the vertex. We have to identify those correctly first. And those are also going to be the x-intercepts of the graph. So what is the P and what is the Q in each problem? So what is the P and what is the Q? Because if you don't identify these correctly, obviously you're going to get the vertex wrong. So here, the P is not negative 3, the P is positive 3. Here, the Q is not positive 4, it is negative 4. And the reason why is because when you're looking for an x-intercept, isn't the x-intercept, well, I don't want to go into more details, but if you set the factors equal to 0 and you use algebra to find that, you're going to get the x-intercept, right? So if you set the factor equal to 0 and then use your algebra, you're going to end up getting the x-intercept, right? So if you set these factors equal to 0, then you can find the x-intercepts. So in number 2, what is the P and what is the Q? So you got to make sure, and that's the biggest error that I see every year, is people don't get the right vertex. They can't figure out why their graph is wrong. It's because they didn't have their P and Q correctly. So you need to make sure you identify your P and your Q. So the P is not positive 6, the P is negative 6. The Q is not positive 2, the Q is negative 2. So we have to be identifying those correctly. In number 3, and then notice this would be opening down, and it would have a vertical stretch of a factor of 4, but it would be opening down. This one's opening up. This parabola is going to be opening up, And then what is the P and Q in this problem? Right? The P is actually 0. And the Q is not -7, but 7. Right? Because couldn't we write that as 6x minus 0 and x minus 7? Isn't that the same thing? Right? Next, that collapses to just x, and then x minus 7. So it's 0 and positive 7. So you got to get those P's and Q's down right. For the next one, this we can identify this Q very quickly, but this P, we have to set it equal to 0 and use algebra, and we get 1/2. This one you can set equal to 0 and solve, but right, that's easy. You could just do that one in your head. So this one is easy, we just do it in our head, but this one you're going to actually have to set it equal to 0 to find it. So this P is going to be 1/2. And this Q, we can see it's not a positive 5, but a negative 5, because when you use your algebra skills, you undo it. So the positive 5, the Q is actually -5. So understanding your P's and Q's. Okay, so now that we understand how to identify the P's and Q's, how do we graph something that's intercept form? Okay, so here's our first problem. So in this problem, we have to identify our P and our Q, and we know it's opening down. So we know the problem is opening down. So if your parabola is not opening down, you know you've done something wrong. The P is not +2, but -2. And the Q is not -4, but +4. And remember, those are our x-intercepts. So we now know that -2, 0, and +4, 0 are the x-intercepts. Right? So we know that -2 and +4, 0 are the x-intercepts. Those are your P's and your Q's. They're the x-intercepts. And I want you to put them in the t-table. Now, think about it. If our parabola has symmetry, then wouldn't the axis of symmetry have to be right in the middle of the x-intercepts? So can you visually see where the axis of symmetry would go? Right? Where would the axis of symmetry go? Because it has to be in the middle, because it has symmetry of the two x-intercepts. So if this is 1, 2, 3, 4, 5, 6 units, 1, 2, 3, wouldn't the axis of symmetry have to be here? So we'd have 3 units on each side. So I already know where the fold line is, or the axis of symmetry line is, because this has to be the same distance. So how do we actually, and we know our vertex has to somewhere be on this line. So we know our vertex has to be 3 something. So we know our vertex has to be 3 something. But how do we actually get it without visually looking at a graph? We use the formula to find the x. So to find the x, we're going to do P plus Q divided by 2. Sorry, it was a little sloppy. P plus Q divided by 2. So that gives us, so our P was -2, our Q was +4, and the formula says we're adding our P's and Q's divided by 2. So that's 2 divided by 2, which is 1. And that doesn't make sense because I just said it was, yeah. So this is actually my axis of symmetry, or AOS, is x equals 1, and I said 3, and that's not true. It's not 3, it's over here at 1. Ihole, as Grandma Vera would say. Right, so the axis of symmetry is x equals 1. You should always write an equation and never just say 1 for axis of symmetry. So we know it's 1 something, right, which we could see halfway through. It's going to be somewhere on this axis symmetry line, or vertex. And now we're going to plug 1 in. So we've got -1 plus 2 and 1 minus 4. And then you just do what's inside the parentheses first. Multiply. -9 times 1 is +9. So let's double check that. I put in 1 for x. 1 plus 2 is 3. 1 minus 4 is -3. That's -9 times a -1 is +9. So 1, 9 is my vertex. So 1, 9 is my vertex. So I can plot 1, 9. And if something looks a little weird, so if something seems to look a little weird, look at your vertex, because most of the time it's a vertex error. Maybe it should be a little bit lower, a little bit higher if it's off a little bit. Now you can start to see the parabola, but we need another point or two. So I'm going to pick some points in my t-table that are between or on the outside. I'm going to pick either one side, somewhere on the left or the right of the vertex. And I've already picked -2, so I don't need to plot that. So I'm going to pick a few points somewhere either to the left of the vertex or to the right of the vertex. And obviously I'm not going to pick -2 or 4 because they're already in my t-table. So I'm going to pick 0 because that's easy to work with. And then maybe I will pick -1. So I'm going to plug and chug those points. So I'm going to plug in 0 first. So if I plug in 0, that gives me -0 plus 2 and 0 minus 4. So that gives me 2 and -4. So that gives me +8. And then when I plug in -1, that's -1 plus 2 and -1 minus 4. So that's +1 and -5. And that's going to give me +5. And then I can plot those. So I'm going to plot 0, 8. So 0, 8 is right there. And then doesn't it have symmetry? So it's 1 unit away from the axis of symmetry. So wouldn't it land 1 unit away on the other side? And then -1, 5 is right there, and that is 2 units away from the axis of symmetry, so wouldn't it be 2 units away? So now I have enough points. So we don't want you just plotting the vertex and the x-intercepts. We want some extra points in there. So I need to see those extra points. And then if you need to turn your paper sideways so that you can get a good parabola, make sure you extend it and put arrows, right? Make nice parabolas, not those sloppy parabolas. Okay, so that's the intercept form. And again, intercept form gives us our x-intercepts very quickly. That's what's great about that format, is we can identify the x-intercepts really quickly. And then just to practice, does this have a maximum or a minimum? Right, so we say it has a maximum because we're talking about the y values, and here the y values, as you go through the graph, are climbing, they're getting higher, 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 until the y values reach its maximum height, and then the y values start to fall, right? So if you look at the pathway of the vertex, we're talking about the y values, and so the y value is it 1, 9? Is it 1 or is it 9? It is 9, so the maximum is 9. Okay, example number 2. So example number 2, what's our P and what's our Q in this problem? So the P in this problem is 0, and the Q in this problem is +6. So the P is 0, and the Q is +6. So be careful you don't say -6, and it's 0. Right? So we know that the x-intercepts, the y values are always 0. So we know that 0, 0 is one of the x-intercepts, and 6, 0 is another x-intercept. So we've got our x-intercepts is 0, 0 and 6, 0. Right? For our x-intercepts. And then we need to find the vertex. So again, we can look at our axis of symmetry. It has to be in the middle because it has symmetry. So I've got 1, 2, 3, 4, 5, 6 units. So 1, 2, 3. So my axis of symmetry is going to be right down the center. And your axis of symmetry, and what's the equation for the axis of symmetry? It'd be x equals 3. So we already know our vertex is going to be 3 something. But again, if we weren't using the graph paper, we would use the formula. So we're going to use the formula to find the vertex. So our P is 0, our Q is 6, and remember the formula says we're adding our P's and Q's. And so 6 divided by 2 would be 3, just like I said. And then we got to plug 3 back into the original equation. By the way, I would take out the 0.25, and I would write that as 1/4. It's so much easier to work with fractions. I know you guys are fearful of fractions, but I want to emphasize that it's so much easier just to work with fractions. And you guys need to learn to work with fractions. So we're so afraid of working with fractions. So we need to plug in wherever there was an x, right? We need to plug in 3 because that's what we got for x. And then we need to do the math, which means we're going to do 1/4 times 3. So you put a 1 underneath that. That's 3/4. And then 3 take away 6 is -3. Put a 1 underneath that. Doesn't that give you 9/4? And that's going to be a negative 2 1/4. Right? So negative 2 1/4. So we plot 3 and negative 2 1/4 is half of a half. So about right there-ish. So you can start to see your parabola. Now we're going to pick a couple more points, either to the left of the vertex, so this is our vertex, or to the right of the vertex. And I've already got 0 in there, so why not pick 1 and 2, or maybe even, how about we pick 4 and 5? Or actually, let's go out and pick like -2. So let's pick -2, something over here, and then maybe let's pick +1. So I'm going to pick something on this side. I'm going to pick maybe -2 to see what's happening after the x-intercept point, because we already know what our graph is going to look like. So I want to get some points out here, and then I want to get some points by the vertex, and then I want to get some points out further out. Does it matter really which points you pick? No. Just pick some points, plug and chug. The more points you pick, the more accurate your graph's going to be. So again, I want to pick some points maybe a little bit further out on my x-intercept just to see what's happening out there. So when I plug in chug, that's going to give me, so I'm going to plug in -2. So that's going to give me 1/4. Remember, I'm changing the decimal to a fraction, times -2, and then -2 minus 6. So that's 1/4 times -2. -2 minus 6 is -8. Now notice, I'm going to multiply these two first. That's why it's important for you guys to learn to work with fractions. Because when I multiply 1/4 times 8, isn't that just cutting that into 4 equal pieces? So that, recopying that, so 1/4 times 8 is -2, and then that's +4, right? So we need to be able to work with fractions and without a calculator. And then I'm going to go back and do that again, and I'm going to plug in 1. So if I plug in 1, that's going to give me 1/4, because I changed the decimal to a 4th, right? So I changed the decimal to a 4th to work with it better, and that's going to give me, I'm plugging in 1 where the x's are. And so 1/4 times 1, obvious 1/4. 1 minus 6 is -5. So that equals, put a 1 underneath that, -5/4, which is -1 1/4. And then when I plot those 2 points, so I plot -2, +4, and that is 1, 2, 3, 4, 5 units away from the axis of symmetry. So 1, 2, 3, 4, 5 units away on the other side. See, my parabola is getting much better. And then +1, -1, that is 2 units away from the axis of symmetry, so I need another. So now I've got a good, decent amount of points to graph that parabola. And I'm not really hitting the points really well because I'm trying to do it with this, right? So, and make sure this curve is nice and soft, right? It's not a V curve. It should be a nice soft curve. And make sure your points are easy to see. They don't have to be super large. Okay, so one last thing. What about this problem down here? What about this example, the last example? What is the vertex? What is the vertex of this one? So let's use the formula. So what's my p in this problem? So to get the x, we're going to do p plus q. So we're going to add the p's and the q's. So my p in this problem is -3, and my q is +2. So that gives me -1/2. So I wanted to give you a fraction to see if you guys freak out. And then if you plug that into the equation, you get 2 times -1/2 plus 3, and -1/2 minus 2. Right, so if you have 3 whole pizzas and you're taking away a half, doesn't that leave you 2 1/2? And -1/2 minus 2, isn't that -2 1/2? Right, so when we do what's inside the parentheses, that's pretty easy. And when you're multiplying fractions, don't we want to change them to improper? So 2 times 2 is 4 plus 1 is 5 halves, times 2 plus 2, 2 times 2 plus 1, right? Change it to a mixed number to an improper is -5 halves. And then we can cross these out, and doesn't that leave me 25 over 2, which is a negative? So isn't my vertex negative 1/2? And then I'm just double checking. So 2 times 2 is 4, plus 1 is 5, and then it's a negative answer. And then I went ahead and cross canceled, then I multiplied numerators and denominators, and then isn't that 2 going to 25 12 times? So isn't that negative 12 and 1/2? So we should be able to work with fractions. The fractions we give you shouldn't be that complicated. So I need you guys to work with the fractions. Okay, so that's graphing parabolas in intercept form. And intercept form tells you where it's going to cross the x-axis. So it tells you the x-intercepts. And this form is a really helpful form. And then, by the way, does this have a maximum or a minimum? Did you say it had a minimum? And what is the minimum? Well, I don't know until I know the vertex, right? So the vertex is 3, -2, so it should be a -2 because -2 is the lowest it goes, right? -2 is the lowest it goes, so the minimum is -2. Ciao, ciao.